And now we discuss a related topic, which is the impulse. Impulse. So the impulse in some books you will also, if you read the high level books, so it is also known as the kick force. So the kick force means that when the force is applied, when the large force is applied for the short period of time, so this type of force is called the impulse. So when the force is applied, there will be a change of the momentum of the system. So the impulse we can write is the force multiplied by the time that the force is applied, and this time is usually in the impulse is extremely short. So we have the relation that we calculated using the relation between the momentum and the Newton's second law of motion, and then we got the relation was the final momentum minus initial momentum. So the final momentum minus initial momentum, so we can also write, so this term here is the impulse, which is represented by I, and this is a vector, and we have the final momentum minus initial momentum, so this is the impulse. So the examples is that if we, so for the example, we will take an example of a ball when it hits the ground. So example, we have a mass which is m, and we drop it on the floor. So it will have some velocity. So this velocity is equal to 2gh. If you remember, we calculated this velocity in our very first lecture when we were talking about the dimensions. And this will be equal to the final velocity after it hits the ground. So this is the example of the collision. So when it hits the ground, so it might come back with the same, in the case of the elastic collision, it will come back with the same velocity. So the initial velocity and the final velocity will be the same, which means the kinetic energy before and after the collision will be the same. Now what we see here, we are discussing here the change impulse, and the impulse is the change in the momentum. So in the change of the momentum here, and this is, for example, this distance is h. So in the case of the elastic collision, so we take the example of the elastic collision. So for example, we have a billiard ball, or we have a ball which is very perfect, and when it hits the ground it will come back with the same velocity. So this velocity and when it comes back, this velocity will be the same. So the change in momentum, because we have the momentum which was mv and it comes back with the same velocity, so we have again the mv. So the change in velocity is the the change in velocity is the impulse. So the impulse in this case will be 2mv. So this is in the case of the elastic collision. In the case of the inelastic collision, the change in the momentum will be only mv. So we have the m and then the v. Why? Because initially the mass will have some velocity, and also mass, so we will have the momentum, but after the collision, that for example, if we drop an egg, for example, on the floor, or we drop a tomatoes, for example, on the floor, so these things will not come back. It will lose its velocity or the kinetic energy, and it will be converted to some other forms of energy. That means that the change in the velocity or the impulse will be mv. In the case of the elastic collision, we have the 2 mv. Now we just, to give you some ideas, we will take the example. For example is we have the m equals 0.1 kgs, and we have the velocity is 5.5 meters per second. So we have this, we drop something, a mass, we take the same example. So we have a mass, for example, here we have the mass is 0.1 kilogram, and then its velocity is 5.5 meters per second. So in the case of the elastic collision, so when it hits the ground, there will be a force. The floor and the ball will feel extremely high force. So, and this force here we can calculate. So we have the force. So from that relation, we can write that we have the impulse divided by time. So we have the impulse is divided by time, and if for the elastic collision, if we use this relation here, 2 mv, and then we divide by time, and the time that we have is because the time of the collision time is extremely small. So when it hits the ground, it will immediately come back, and it's we consider as the 2 millisecond, or we can write 0.02 seconds. So if we put the values there, so we have the we have the impulse here, we have for the elastic collision, we have the 2 mv, and we have the m, we have the v, and we have 2 here, and the time here is the 2 milliseconds, or 0.002 seconds. If we put these values there, the force that we will get is the 550 newtons, which is extremely high force. So whenever we drop something, as we discussed when we were discussing the acceleration, I give you an example. Then whenever we drop something, the change in the velocity is extremely high, which means the acceleration is very high. And we calculated for the ball that it hits the ground, the acceleration is high. And now, since the acceleration is high, according to the Newton's second law, the force will also be high. That's why whenever we drop some hard object on the floor, since the acceleration is very high and also the force is extremely high, that's why the things will break. So this is the example for the elastic collision. We use this impulse, which was 2v. And now we take the example of the inelastic collision. And here the example is, for example, a ball. And for the inelastic collision, we can use the egg, for example, or we can use the water, for example. In the dams, when the water is dropped on the electric generator, and initially the water has extremely high speed. For example, we have a flow of water. So we have a small hole, for example, and this is a water that is coming here. So we have a flow of water and we have a generator here. So this kinetic energy here is transferred to the electric energy by the generator here, and we want to know what is the force that is applied here. So if we use the inelastic case, so in the case of water, for example, which will be inelastic case, so we will get that the I in the impulse will be, we know, is m and if we use the same values, for example, the water that is coming is 0.1 kilograms per 2 milliseconds, and we have the velocity of the water is this one, just to give you an idea. That's why we will use the same values. So the impulse divided by time, and the impulse is there, we have the values there, so we have these values, and if we put these values, so we will get 275 newtons. So this is the force that is applied on the generator because of the change of the momentum. Initially, the water has the momentum, water has the velocity, and if it hits the ground, the velocity becomes 0, and the change in the momentum is mv here, which is impulse, and when we calculate the force that will be applied on the generator is 275 newtons. And now we will discuss the idea or the concept behind the rockets. So our topic is now the rocket. So rockets, how is the rocket working? So we discussed about the change in the momentum. We talked about that the impulse is the change in momentum, and it's the force that is applied for the very short amount of time. So we take the example, and we, for example, throw a lot of objects or some mass on the wall, for example, and there will be a change in momentum. So change in momentum. And since it's the inelastic collision, and we just discussed that for the inelastic collision, the impulse will be mv. So we just discussed that when we were talking about the impulse. So now the change in the momentum is mv, but we are throwing many objects. So not only one m, but we are throwing many objects, and this n is representing the number of the objects. For example, I throw, for example, 100 objects, 100 tomatoes or 100 eggs on a wall. And this is then, for example, 100 or 200, so this is just a number. So this is the change in momentum. And now, so we can write the change in momentum per unit time. And we know that the momentum is mv divided by time, and this is equal to force. So the change in momentum that we have already discussed, that the change in momentum with respect to time is the force. And now, so this is the mass that is thrown per unit time, and we have the velocity of that object. So to understand it better, I will just give you an example. For example, there is a person. So there is a person, and we throw eggs on this person. For example, we have this egg, and it has initially its velocity is 0, and we throw it with the velocity, we apply a force, and its change in velocity, this is the Vx. And this person is feeling, when it hits the person, its velocity is Vx, and after the collision, the Vx becomes 0. So this becomes 0. And due to the change in the velocity, this person is feeling the force. Since this person is feeling the force, according to the Newton's third law, if this person is feeling a force, the person who is throwing the egg should also feel the force. So in the opposite direction. So this person, for example, is throwing the egg, for example, and this person will feel the force. And this force is the idea behind, or the concept behind the rocket. So this person, when we throw some object, for example, initially the egg velocity was 0, and from 0 to Vx, so the change in velocity means the change in velocity means that there is an acceleration, and this acceleration is caused by this force, and this force the person will feel it in the opposite direction according to the Newton's third law. And now we come to the rocket. So we have a rocket. So this is a rocket, and rocket is throwing a lot of air, gas in this direction. So what's actually happening is that this is our mass per unit time. So this is the mass per unit time that the rocket is throwing. Since this rocket is throwing the mass per unit time, and if we throw something in this direction, it will have some velocity. So we have the velocity, and we just discussed if there is a change. Initially the velocity of this gas was 0 when the material was inside, and when it throws in this direction there's a change in velocity, and according to the Newton's third law and also the second law, this rocket will feel a force in this direction, and this force is called the thrust force. So this is the physics behind the rockets. That's how the rocket is working. So if the mass per unit time is high, so if the mass per unit time is high, which is directly proportional to the force. So if the mass per unit time is high, means there is a lot of gas that is coming out of the rocket, means that the rocket will feel a very high thrust force. And if the velocity of the gas that is coming out is also very high, which is, we can see, which is also directly proportional to the force. So this, either if these two are high, this force will be extremely high. To give you some examples or to give you some feelings, I will give you the real values that were used in the rocket that was sent to the moon in 1969. So the rocket name was Saturn. So example is the Saturn. So this rocket was sent to the moon, and we want to know how much mass was coming out of the rocket and how much force that rocket felt, and what was the velocity of the fuel that was, or the gas that was coming out of the rocket. So the speed that was coming out of the rocket, so the speed of the gas that was coming out, so equals velocity was 2.5 kilometers per second. And the mass coming out is mass divided by time. That was 15,000 kilograms per second. So right now we have the mass per unit time. So we have the mass per unit time, for example, here. So we have the mass per unit time, which is 15,000 kilogram per second, and we have the velocity. So we can now calculate the force, which is this force. So we have the mass per unit time, we have the velocity, and we can calculate that how much force the rocket felt when it was sent to the moon, the first rocket that was sent to the moon. So the force, thrust force, is equal to 35 million newtons. So this is extremely high force. So if you remember, when we drop a ball and due to the change of momentum, the force was 550 newtons. And here we have the 35 with 60. This is 35 million newtons. It is extremely high force.